Hi everyone, welcome back to the channel. This is oksbi. Previous video we have discussed about logistic regression in machine learning algorithms. Today I am going to explain about decision tree. What is a decision tree? How it's work? What are the things attributes we are finding the decision tree? Advantages and disadvantages. Or all these things today we are going to discuss. Before going to this decision tree algorithm, if you don't watch my previous algorithm videos, please make sure watch that and after come here. Okay, let's move into that. Actually, what is mean by the decision tree? Decision tree is a supervised learning technique that can be used for both classification and regression problems, but mostly it is preferred for solving the classification problem. In decision tree there are two main roads. There are the two roads, but one is decision nodes and second one is leaf node, where the leaf node is the final one. And basically the decision trees forms only one parent node, two childs, like there is that is known as leaf nodes. In order to build the decision tree we use the cart algorithm, where cart algorithm means classification and regression tree algorithms. Why this came over here means it can work for the classification problems and regression problems also. Actually, how the properties of this decision tree is it contains low bias and high variance. By using this low bias and high variance, so there are a lot of algorithms to solve this, but in this case the decision tree have low bias and high variance. Okay, let's see the example. This is a simple example how the decision tree is formed. Decision tree is mainly known as decision. We want to take the certain decision. How here, for example, in this example, is a person is fit or not. Above there is a node head node, decision node as age greater than 30. If S, it is a leaf node. If S, they have come occurred to the S, right? No, they are going to exercise. These are the things are formed in the decision trees. Okay, let's move. How to find the major attributes of the decision tree? The best decision tree, how to find? And there is a two levels, two steps or two levels are there. One is information gaining and second one is gain index. In this information gaining we have entropy thing. What is mean by entropy? Entropy using the splits of nodes. Why this entropy came over here means we want to find the best split. At time only that information gain is perfectly worked. How to find this best entropy at best split? Let's move into that. There is a use of formulas. H of s equals to minus ps log 2 ps minus p naught log 2 p naught. This is a formula. Let's just see some of the example. I will explain about this. Okay, take over here. This is a thing here. F1 we can see this is a 5s and 3 nodes. How to find this entropy for F1? Entropy, we have know that the formula is H of s is equals to minus p of s log log 2 p of s log 2 p of s, sorry for my bad handling, and minus p of no log 2 p of no. This is a formula where we have, okay, Here the P of S means how many S's are occurred. Okay, here the SS is 5. So where the SS is 5 means P of probability of SS, where the probability here the occurred the probability, that's there is a total number of is 8. So we can solve like this by using this formula. H of S is equals to probability P of S means 5 by 8 log 2 probability of P of S is means 5 by 8 minus, here the minus is friend, probability of P of nose is 3 by 8 log 2 of 3 by 8. Now we want to calculate this thing, where it will occur approximately 0.89. This is approximately value, perfect not value. You can calculate like this. This is the thing where H of S, where F1 entropy is 0.98%. It is entropy of F1. So let's move into that. We have find the entropy, and this is like this we can find the entropies. And the next one is information gain. How to find the information gain? Average of all entropy. Average of all entropy. So here we have find entropy for F1 like this. If we have a lot of bits, like we have a lot of decision trees, we want to find the each and everything entropy. We want to find each and everything like this. We want to find, this is the thing. For after finding this is F1, F2, F3, F4, F5. For finding all the entropies, we want to calculate this information gain. There is one of the formula is there, information for information gain. Information gain is equals to entropy minus weight average into entropy of each. This formula is here, but we can have another formula also for an gain, information gain. Information gain equals to H of S, or we also write like this, G of S comma A. H of S equals to summation of P belongs to values mod of S of V SV by mod of S into H of SV. Yeah, where here we know the here mod of H of V is, it is after split. After split. Okay, where this is a sample, and this is a entropy. This is a formula we have to solve these problems. Okay, and how to implement this? Whereas we have get first F1 entropy. So for this case we have 3 types. This decision trees have 2 things, and again these are split into 2 types. Here the F1 One is 9 by 5. It means 9 S's and 5 nodes. Here we have split this 9 by 5 into 6 by 2, and F3 is F3 is 3 by 3, where it has 3 nodes, 3 S's. We want to find these things. Okay, this is total number of F1 is 9 by 5, and we want to find the entropies for this. After, for example, we have get entropy like here is 9 by 5, 0.91, and F2 entropy is 0.87, 0.09. These are the entropies we get. Sorry, it's a 0.9. Y means 3 by 3 equals to 1, like that. Find this entropies like before we have done here, like this. We want to do the entropies here. After finding these entropies, we want to substitute this in this formula, like h of s means 0.9 is the high one, entropy of split. One into here the minus summation of after split by total sampling. Where the after splits have happened here is here total splits is 14. 14 divided by 14. There is a here is 6. 6 plus 2, 8. 8 by 14 into h of s, h of f2. F2 minus here we have 6 total splits are 14, and 3 S's and 3 no's are 6 plus 2. 6 into h of F3. So where we have get this is 0.91 minus we can have 18.8.4 into where we get f1 is into 0.87 minus 6 by 14 into we have get into 1. By calculating this all thing, we have get 0.049 approximately. It's not definitely answer. Again, we have calculated this. We have get like this. Okay. After this, we have find up to now what is entropy gain information. We have another method. It is gain index. How to find the gain index? Gain index is a measure of impurities or purities used while creating a decision tree in the CART algorithm. And attributes with the low gain index should be preferred as compared to the high gain index. That means if any low values contain low index, it will change into the height index. That is the main property of the gain index. It also created the binary splits and CART algorithm used in gain index to blend the binary splits. Whereas again, these are using formula of gain index. Gain 1 is equals 1 minus summation of I or summation of IRP summation of P whole square. This is the formula. Summation of J into B J whole square. This is the formula. We can find it. We can also write as gain index or gain index. The formula is 1 minus summation of I equals to into I equals to 1 to n 1 to n into p of p square. This is the formula where 1 minus summation of I into there is a positive and negative like yes or no. So we have p1 plus p minus whole square. It means this is s and this is a nose. S or nose. Okay. 1 minus we can get here is 8 by 6 SS is we have a get as a SS is 6 by 2 whole square and 3 by p of 3 is equals to 3 by 3. When we calculated this around we have get is 4 square plus 117. By this by doing this we have get approximately we have get the value of 0. Like 51 something approximately. This is a process of finding these entropies, and let's move into that what is how to get optimal decision tree. Purring for that case we have one of the technique is purring. Purring is a process of deleting the necessary nodes from the tree in order to get optimalities. It means it wants delete unnecessary nodes which are contained in the decision tree. There is a two main purring techniques, that is cost complexity purring and reducing error. This is all overall about this decision tree, how the working of decision tree, what type of working we have to. Let's move into the detailed advantages and disadvantages of decision tree. First is advantages of decision tree. It is simple to understand and it follows the same process which a human allow like making a decision in this real life. It can be very useful for solving the decision relating problems. It helps us to think about the possibility outcomes of a problems. And number 4, there is a less requirement of the data cleaning compared to the other algorithms. It is a main thing. It is a main example of this. And disadvantages of this decision tree is decision tree contain lot of layers which make it complex. It may have an overfitting issues also because decision tree has a properties of low variance and low bias and high variance properties. To do that, it will show the overfitting issues. For that case, we have an algorithm, random forest algorithm, that will solve this overall things. The next one is for more classes labels, the computation of decision trees may increases. Computational complexity is increased in decision trees due to the more labels. These are the things about the decision tree. If you have any doubts, please make the comments. I will explain. And do you want to learn more about the data science or any new technologies or aptitude, please make sure to follow our YouTube channel. Okay guys, take care.